Welcome back to the CoderCon, guys. Today we are building something used by hedge funds and risk managers all over the world, a Monte Carlo simulation. Yes, in our last video, we tried to predict exactly what the price would be tomorrow. But in the real world, the future isn't a single path, it's probabilistic, it's multiverse. Think of this like Doctor Strange looking at 14 million possible futures. Today we are going to write a Python script that simulates 1000 different timelines for Tesla stock over the next year. Some timelines will crash, some will moon, some will stay flat, but by averaging them all out, we get the fair value. This code involves some heavy math, specifically geometric Bauman motion. I'm going to break down every single line so you can understand the physics of the stock market. So let's begin with it. Basically, I'm putting the name is at it as a Monte Carlo simulation bot, a Monte Carlo bot.py because it is a mini Python. Basically, this is the same stick we should use as usual. You'll see. Basically, I have also done hedgebot.py and mastersbot.py as well as mlbot.py. You can check it in my previous videos as well. I will mention the link in the comment section or description. So here we go with the libraries. As you will import libraries, we just first import yfinance as import yfinance because we use Yahoo Finance for importation. Then we import pandas and numpys and matplot. This is basically the basic, which is called a basic importing libraries for the general quantitative finance or quantitative trading. So the second thing will be what we will do is now in configuration, right? So now we will just go with the first thing, which will be configuration. So as you know that we always do it Tesla. So as usual, we will mention ticker Tesla. Then we will use simulation, which is 1000. Simulation is 1000. The reason is because we will simulate 1000 different futures. What can be the possibility of one stock? How much it will go in different prices? These 1000 futures will be related with it. So the second will be days ahead. Now what is days ahead? Basically, I will just tell you in description. It will predict the next 1 year. So as we mentioned to this, the graph which will be created after writing the code, it will show the data for next 250 days. Yes. So then we will just print the Monte Carlo initiated and then ticker use. And we will use it as tickers. So the next thing will be fetching the data. Basically, how do we fetch data? Basically, we fetch it through Yahoo Finance. As you can see on line 14, yfinance download we have used. Then we will go to ticker because Tesla is the mainstream ticker section. Then you pays a period for 2 years. Yes. Then we consider progress is equals to false. If instance data columns dot pd multi-index. This line is used basically to get the instance of all the previous data which will be used in the mentioned code for the given functions. Then we'll go check the by 18, which is written out that get the every last price to start assimilation from. The latest last price for the data, which will be from the previous day. That means the yesterday's day. If we analyze the data from the yesterday's day, and then we can, if we give us the data for the yesterday day. Then we will go for the math, the drift and the volatility. As you know that volatility is the most important thing. The stock which is today in the section can't be in the Fermi section, which is where we will use this at a volatility section. So after that, the volatility is derived. Then you will go with the volatility section. This is the most crucial section. So okay, if we stop here, this is the heart of the quantitative finance. We need to calculate two things, drift and volatility. Right now, the drift and volatility both the main sections. So let's check line 23. It is log return is equals to np.log. So here, why log return? Why not simple percentage? In complex simulations, simple percentage does not add correctly over time. Log returns add a additive and usually fit the bell curve normal distribution, which is called as with a standard practice in a quant finance. Okay, next step may be from the line, you check out line 26 and 28. As you can see, the drift average bit is equals to average then return minus variance divided by 2. This is the basic formula to calculate the drift. Basically, we will go at log returns as we did before. We will go with var variance and then we will find the derived drift logic through the formula, which is drift is equals to u minus 0.5 multiplied by var. Okay. The next step is the volatility, which is standard deviation. Standard deviation is equals to log return. So right now, what we'll do is the standard deviation. This measures the risk or the energy of the stock. A high number here means our future lines will be wild and jagged. A low number means they will be smooth. So now the section 4 is generating the multiverse. Now we generated chaos. Line 35, you can check over there, the daily returns. This formula is basically the most important formula to get the simulation for the previous days and also deriving it through the next 1000 days or means 1000 futures and 252 days. Rarely this number actually is +3 or -3 huge news, earning shocks and crash. We are generating a grid of these random shocks for 252 days across 1000 simulation. This one line of code essential creates 252 k random. Random market events instantly. Now we have daily percentage moves. We need the actual price. I create a blank canvas called price paths filled with zeros. I see the first day 0 to our last price for every simulation. Then we loop, which is on the line price paths is equals to MP0 like daily returns. Then we'll go for loop through every day and we will just put it in the section of coding. Now areas are the rare outliners. So as you can now see the line 56 and 57. As you can see that basically now we will just, the coding part is all done. Now we will just do the code for the graph which will be, or the chart which will be seen after in the output. So now as we know that we have set plot to n percentile price path basically, and then we will just choose it to not just settle, so that the part will be shown or visible to it. Now the annotation part, basically we will give a plot, we will give our graph a title which is Monte Carlo Simulating. Then we will show it as 1000 futures, and the font size will be around 16 because it is heading session title, and the color will be blue. Then we will give the plot Y label which is the Y axis, label price, and we will give plot X label which is X axis as trading this ahead. We'll keep both the font size around 12, and then we'll put a plot legend which is log physical to upper left. There is the head of the head. Then you will put plot grid. What will the grid? It will be in the color gray form. In the line style will be dot, which is NA, and the alpha will be 0.3. Now the print result. What will be print and why it will print? Final price is equals to price path minus 1, which is the previous path, which is the previous price of it. Then you will, now the end section will be the price distribution section. We'll put it as print current price will be last price, print expected price 1 year, then print best case scenario, then print worst case scenario as well. And you will say said print let's go, the chart window is showing the price and as it had mentioned above. That's it. This is the code